student, my name is Confident. Welcome to our revision session, and we are looking at the paper which was written in April 2021, and this is Mathematics N4. So what I just did was to just select a few questions in this paper. As you can see, this, as I said, was written in April 2021. So it's for Mathematics N4. It's just a few questions, just a short lesson that I want to share with you. And let us look at question 2 in this case. I'll be doing all these questions, and just keep following up on our lessons. Again, if you have not subscribed, I will encourage you to subscribe to our channel so that every time we post a new video, you're notified. You can also switch on that notification bell so that every time I upload a video, YouTube will send you a message. So as I said again, you can forward this channel to your colleagues and friends so that they can also benefit from this channel. So as I said, this is a quick lesson. I will do all the questions for this particular paper, which was written in April for Mathematics N4. I'm doing this out of, I got some overwhelming responses from people who are requesting us to do also this paper. I've done Mathematics N2, I've done Mathematics N3, and I'm yet to do N1, and now this is N4. So let us quickly look at this trig. I'm just going to focus on the first, because of time. I will focus on the first 3 questions of this trig and then see how it goes. Now the question says, if 8 sine theta plus 5 is equal to 0, determine the value of that. So now if I can just let me have a blank page, and I've got my formulas, is fine, but let me have a blank page and look at this. It says you are given 8 sine theta plus 5 is equal to 0. So if I write that down, 8 sine theta plus 5 is equal to 0. So this is what they've given us, and then they are saying we need to determine the value of, now what we're given now is cos squared theta plus 10 theta cos theta, and then it says without using a calculator. So I'll show you both methods, how you can use a calculator to test. This is where you will test your answer, but without a calculator you need to solve that cos squared theta plus 10 theta cos theta. So we are looking for cos squared theta plus 10 theta dot cos theta. So that's what we are requested to find. So what do we do in that case? So if you're given 8 sine theta plus 5 is equal to 0, you can do this through the sketching of a trig diagram, which I'm going to show you. But first things first, you need to solve this equation, whereby you take your 5 to the other side. So you'll have 8 sin theta is equal to -5, and then you divide by 8 on both sides, such that you have got now sine theta is equal to -5 over 8. So if this is our sine theta, now if I can go back in this question, usually they give you a range to say theta is between this value and this value, but they didn't give us that. Now we're going to work with it like that. So what I need now is to sketch my diagram. If I sketch a diagram, in this case the diagram what I'm talking about is this particular sketch, where, let me just make it even like that. So what I will have is, remember, this is my y, this is my x, and I need to now sketch. Now if you remember what is sin theta in terms of x, y and r, it's y over r. That is sin theta in terms of x, y and r. You need to know SOHCAHTOA and how you convert adjacent, opposite and hypotenuse in terms of x, y and r. Now r is the hypotenuse and y is the opposite, x being the adjacent side. So now we are given that sin theta is equal to minus 5 over 8. Now where can I draw this diagram? So you can see that y is negative, so I can either draw this diagram here where y is y there. If you can compare now, what I'm trying to say is the y is minus 5 and the r is 8. That's what I mean when I'm saying you're drawing that. So you've got y being minus 5 is on the negative, and you can draw this diagram down there where y is negative. Remember, y is negative at the bottom, but now I need to find the value of x. So what I have here, I've got that. So what I have here, I have got the value of x, which I'm going to find, and the value of y is negative 5. Why am I saying that? If you take it here, you will have a negative 5 for y. So now we need the value of x here, and that value of x is what we're going to substitute for that. So how do you find the value of x? Remember r in this case. So we have got our y being 5. You can see the triangle that I'm dealing with now. This is the triangle that I'm dealing with from that point to that point and that point. I hope you're able to see that particular triangle. And as I said, the 5 is the y and the x there is the adjacent. So now actually I'm not drawing this triangle right. Let me draw it the other way around because it changed things. Let me draw it like this. This is actually the right way, like that. Yes, that's the right way, like that. So what I'm having this as 90 degrees, and that angle there, the angle there, we can actually, the angle starts all the way from the x-axis and anti-clockwise. So if we call that angle theta there, you can see that x is the adjacent and y is my 5 in this case, but it is negative 5 as you can see. So now to find, and then I've got my r, which is 8. To find the x in this case, which is my x, is the theorem of Pythagoras, which says x squared is equal to 8 squared minus, now y is minus 5 squared. Remember, it's based from x squared plus y squared is equal to r squared. This is the theorem of Pythagoras, which I suppose you know. So x is equal to square root of 8 squared, it's minus 5 squared. So if I check that with the calculator, I will have square root of 8 squared minus negative 5 squared, and then it will give me square root of 39. So I've got x being square root of 39. So that's what I have here for x as square root of 39. So with that in mind, now that is one place where I could have plotted this. Now let me say, because they didn't give me the place where I can plot it, I can also plot it in this other direction. Let me use a different marker. I can also plot it in this other direction like that. Now if I'm going to plot it in this direction like that, what I have here, you can see the triangle there, 90 degrees, and this is also my angle. Now this is my angle theta, and then in this case this is my y, and this is my x again, and this is my r. Remember, r is 8, y here is negative 5, still at the bottom, but x is going to be positive in this case. So in our scenario, here the answer here is supposed to say plus or minus. So x in the first case, because you can see that it's on the negative side, is negative 39. That I must emphasize. X is negative 39 this side, but here on the other side, x is positive 39. You can still use the Pythagoras theorem to check that on one side x is negative 39, the other side x is positive 39. So the question was in a way supposed to give us to say the values of x are between which quadrant and which quadrant, but in this case they didn't specify. So now the next part they were saying, now we need to solve this question which says cos squared. Now when you've got this diagram, it's easy now for you to simplify things. Now if you are requested to solve cos squared theta plus tan theta dot cos theta, now you can then move on to say cos, remember cos is x over r squared, plus tan is its opposite, which is my y, over adjacent, which is x, multiplied by cos, which is x over r. This is basically what you are supposed to have. Now the x, remember, if you start with the 1 on this side here where it's negative, so you've got x being negative square root of 39 over r, which is 8, and then you square that, plus my y in this case is minus 5, and my x again is negative square root of 39. You see that? Multiplied by x being in this case negative square root of 39 over my r, which is 8. So if we simplify that, what you're going to have, I think you can see that this cancels out there, but you can still use a calculator once. It can give you the answer straight away. So if we do that, what I'll be having is I've got minus square root of 39 over 8, and I've got that squared, and then plus I've got that as negative 5 over negative square root of 39. Alright, I hope you are able to see that. And then with that again, you open another bracket, which is negative square root of 39 all over 8. You multiply that like that. Then if you give the answer, it is minus 1 over 64. So you see that this is equal to negative 1 over 64. Alright, so now let's look at the other version, whereby in this case the r, remember here it was when x was equal to negative square root of 39. Let's look at this side when x is equal to positive square root of 39. You apply the same way. So when you say cos squared theta plus tan theta dot cos theta, and then cos squared there will be, in this case, square root of 39 over r, which is 8 squared, plus 10. Now remember 10 is y, still minus 5 over, now it's positive 39, and then you do the same thing as square root of 39 over 8. Let's see, maybe the same answer will be obtained in this case. In a way, maybe the paper or the question or the examiner wrote it in such a way that it gives the same answers in that case. So let us look at this and see what it gives us. So if I look at this and say what I have is square root of 39 over 8 squared plus, and I have also bracket square root of negative 5 over square root of 39, and I multiply that with again square root of 39 and then all over 8. So this is what I'm having, and then my answer there is minus 1 over 64. So I think in this case that is the reason why they didn't give a range, because whatever quadrant it is, this gives the same answer. So now, what if someone was testing this just to check if ever the answers were going to be the same? So what I was saying is, whenever you're going to be testing this, when they give you this part here to say 8 sine theta, remember this is equal to 5, we divided, it was negative 5, we divided by 8, and we agreed that sine theta was equal to minus 5 over 8. But they say don't use a calculator. Let's say you're using a calculator. This theta is arc sine minus 5 over 8. Now, if you do that, you say shift arc sine bracket negative 5 over 8. And let us see the angle that we're going to get. So this is the angle is minus 38,68. So I'm going to put that, if I do this and say answer, you see the calculator always maintains my answer. So even if I say AC and say answer, the calculator always maintains. So I'm going to put it in cos squared. So what in that question, it is cos and then answer and then squared. Remember that answer I have plus 10. And then the 10 theta is 10 answer times cos answer. If I do that, I must get minus 1 over 64. There is the answer, minus 1 over 64. So which means this is actually correct. So when you take the angle that we got here and you put it in each side for theta, it gives us minus 1 over 64, showing that our answer therefore is correct. So that is how you do that question. And the other one, 2.2 here, it says prove that cot 90 plus theta is equal to minus 10 theta. Now if I can try to prove that, look at that, I'm given cot 90 plus theta. I'm taking my left hand side, so that equal to, now remember cot is in a way 1 over 10, and 10, remember 10 theta is equal to sine theta over cos theta, that is 10 theta. Therefore, what about cot theta? Cot theta is the opposite, which is cos theta over sine theta. Alright, so using that identity for cot 90 plus theta, you are going to get cos 90 plus theta over sine 90 plus theta. So now what you need to do whenever you've got cos and sine, you remember now these are cofunctions. Cos 90 plus, what you need to remember, you are in this quadrant here. If I can just draw my cast diagram, it's very important to always remember your cast diagram. Now in the cast diagram, 90 plus theta is in the second quadrant, and in the second quadrant sine is positive, cos is negative. Now with the cofunction cos 90 plus theta is equal to minus, because cos is negative in this quadrant of 90 plus, cos is negative, so you take the sign of cos, which is minus, but the cofunction is sine theta, over, now sine 90 plus theta, sine is positive, then it becomes cos theta. Then when you do that, now sine over cos is equal to negative 10 theta, which is equal to the right hand side. So I think you can see how that could have been proven in that. It wasn't a difficult one, you could actually have proved it like that. Now the last one here, I wanted to quickly look at it. I said I'm just quickly looking at these, not in total. Say simplify as far as possible. So what they gave me here is sin x plus 10x over cosec x plus cot x. Now you need to know here, change the tan and the cosec and the cot. So you'll have sin x plus, now tan is sine x over cos x, and then all over cosec is 1 over sine x plus cot. I think we did previously to say cot is the opposite, which is opposite of tan, inverse of tan, which is cos x over sine x. Now if you continue that, now this is over 1, the common denominator in the top, you have got your cos x. Now what you have on top here will be 1 into cos x. 1 into cos x is cos x sine x times that plus sine x, that is the top. You must do your fractions over the bottom. The common denominator is sine x, and then I have in this case 1 plus cos x. So if you continue that, now look at this, I can factorize. I've got sine x, I'm going to take it out here in the top, sine x. So I'll have cos x plus 1 all over cos x, and then where there is this division, I'll use this kind of division. I'll say divided by that which is 1 plus cos x. I'm going to use the divided here over sine x. I hope you see already it's coming out, and then you have got sine x on top, which is cos x plus 1 over cos x. Now the division sign, change it to multiplication, which will be sine x over 1 plus cos x. When you do that, you can see that this cos x plus 1 and 1 plus cos x is the one that is actually cancelling out. So what we have in this case, you have got now sine x over cos x here, sine x over cos x times sine x, which is equal to, now sine over cos is tan x times sine x. So in a way, when you simplify this, is tan x sine x, tan x dot sin x. So that is how this can simplify further. Or in a way, you can actually call it, if ever they wanted it like this, whereby you multiply sin x times sin x, it will be sin squared x over cos x. So that is actually different ways of putting it, but at the end of the day, this was how this could have solved up. Now, as I said, the lesson was just a part of this part. In the next sessions, I'll also do 2.4 and 2.5, where I'm supposed to prove this identity and solve for alpha in that. But for now, we've come to the end of our lesson. Again, guys, I'll encourage you to subscribe to our channel so that you can always be notified in real time whenever we post this. We've come to the end of our lesson. Thank you.